started this series on algebraic fractions, I thought it was going to be, originally, I thought it was going to be like 2, 3 videos. And then as I did the first video, I'm like, oh, we're going to break it into 4. And this is a really important topic. And so I think breaking down each issue as they arise in context is really, really important. It helps you find help you might need on a specific portion, and it helps us to go slow. And this is a really, really important topic. And here's why I believe this is a super important topic. And bear with me, I'm going to try to sell this to you here, right? Anyway, by the way, you guys are looking sharp today. Dang sharp. Anyway, um, so look, uh, the one of the limiting things, one of the barriers students face in getting a college degree is a class called college algebra. And the thing that is most difficult in college algebra for students is when they start having to deal with graphing rational functions. And that's all about dealing with algebraic fractions. And I know that because I taught that class for about 8 years. And so I saw a lot of people really, really struggle. They failed over and over and again, and that was a barrier. That was a gatekeeper. It prevented a lot of people that I saw from getting a college degree. And it's really too bad because it doesn't need to be that way. This is a very confusing topic for a lot of students because they never really understood fractions to begin with back in 5th grade, right? So here's my pitch. Uh, this also comes up in calculus too. The difficult thing in calculus is the algebra. It's not really the calculus. It's not the new concepts and procedures that arise in Calc 1. It's actually dealing with the algebra correctly and efficiently. So anyway, off my soapbox, right? But here's my pitch to you, right? So I'm making all these videos on algebraic fractions, breaking things down, trying to take our time and be patient. That gives you the opportunity to really zero in on the specific small things that are causing you trouble. Because once you get your head around them, uh, it's going to get a lot easier. But you got to give yourself time. You got to be patient. You got to ask questions. Don't be afraid. Nobody's born knowing how to do all this stuff. Nobody's born with this knowledge. It's something you have to develop. It's something you have to work on. So putting this together to try to help you out, right? Now, anyway, I'll shut up. We'll get to it, right? I'm going to switch over to the document camera right now. What we're going to be talking about in this video is division. And we're going to break division into 2 parts. We're going to do division like this and one other thing in this video. And in the next video, we're going to be doing complex fractions, which are like fractions inside fractions, which this is a complex fraction. But we're going to do some uglier ones where you have to get common denominators and stuff. We're going to make that its own video. So, what you see on the screen right here is some very ugly handwriting, but otherwise what you also see is you see 3 different expressions, and they're all the same. This and this and this are all exactly the same as this thing right here. All 4 of those things you see on the board right now, on the screen, all the same. Division is multiplication by the reciprocal, right? Now, one of the things that's really tricky is that you can't change the order when you're dividing, and so you have to be really careful about what it is you're taking the reciprocal of. See, we're dividing into this by this, so we're going to be multiplying by the reciprocal of this. Reciprocal is when you flip it over. You see what we did right here, right? Now, before you multiply, you want to reduce, but you got to be careful with division and reducing, right? Now, you see, here's the deal. It's true. You could reduce 3 and 15, but you can't actually do that here because division is multiplication by the reciprocal. So we need to address what this symbol means. It means this. And now you see this 3 and this 15 are not reducible anymore. You see, so you can't actually reduce these 2 right here. That would be a violation. And however, you can reduce this 5 and 15. That's 1/3. If this could be reduced, you could reduce this as well. But you can't reduce across because there's no commutative property of division, right? So with multiplication, there's a commutative property. You can switch things around, no big deal. But for example, 3 times 2 is the same as 2 times 3. But 3 divided by 2 is not the same as 2 divided by 3. See, 3 divided by 2 is 1.5. 2 divided by 3 is 2/3. This is 1.5 and this is 0.6, repeating, not the same at all. But multiplication, you can switch the order. All right. So anyway, multiplication by the reciprocal is what division is. So when you see this, what you're going to do is you're going to take the second part, the second term. You're going to do the reciprocal, flip it over, change to multiply, and then you're going to multiply. Just as we talked about in the last video, when you're multiplying, you want to reduce before you multiply. Muy importante. Saves you a lot of trouble, keeps you from having to do extra work, because when you're reducing, what you're doing is you're unmultiplying anyway. So check it out. 5 goes into 15 3 times, and 5 goes into 5 1 time, so those are done. B and B, those reduce. X and X reduces. All I'm left with is 1 times 1 and 3 times 3, 9. So all three of these up here are going to equal 1/9 when we're all sitting down. Let's see if we can get this focused a little better. A little bit. So multiply by the reciprocal, right? You can reduce a single fraction, but you can't reduce across. And so if we reduce this one first, we would still end up with 1/9 because, well, we reduced to here, right? Now this one right here, let's talk about this. This is a complex fraction, this whole thing. And this is the numerator, and this is the denominator, right? Do you see how this right here is the numerator and that right there is the denominator? This means the top divided by the bottom. Just like this means 5x divided by 15b. 5x divided by 15b. Look at this right here. 5x divided by 15b. Division, multiplication by the reciprocal. So if we took the reciprocal of this right there, it's going to be 15b over 1. If you do the reciprocal, you get 5x times 1 over 15b. And when you multiply that together, this is a whole number, so you put it over 1, and you end up with 5x over 15b. Do you see? Numerator divided by the denominator. Same thing here. It's just trickier because here the numerator is a fraction. Here the numerator was a single number. Here the denominator is a fraction. Here the denominator was a single number. So this means 5x over 15b divided by this. So if you saw, here, let's write it out, right? If you saw this right here, let's see, let me move the paper up a little bit for you. Sorry about that. If you saw this right here, here's what it would mean. It would mean 5x over 15b divided by 3x over b. That's what it means. So it's the top divided by the bottom. The numerator divided by the denominator. Now, it's pretty easy when both are a fraction. It's trickier if this was a single number, or if this was a single number. Like for example, if it was 5x over 15b divided by 7. Then it's hard to see exactly which is the numerator and which is the denominator. And usually the font will have this right here. You see how that's got a smaller fraction bar than that? Or, whereas it would be different like this. Do you see? This is the numerator, and this is the numerator. So it can be kind of tricky to read, and that's why division gets really confusing because of the notation. It's multiplication by the reciprocal. There's lots of ways we can write division. This last one right here, also division. Negative exponent means, well, an exponent is repeated multiplication. Negative means opposite. This is repeated division just one time. So this is also division. So this would be 15b, 5x, and then top, b over 3x. See? Same thing. Same thing as before, and we're done, right? All right, now, whole purpose of showing you all these three things is because I want you to see how to read, and after you read it, then you can understand how you write it. All of these are written exactly the same way. Let's talk about one more example right here. Let's talk about something that's kind of ugly, right? Let's talk about, let's do two more. Let's do two examples. Let's talk about this one right here. 7b squared divided by 14b cubed over 9a. Okay. Now, the temptation for a lot of people is they're going to be, oh yeah, I got to reduce before I multiply, which is true. But you can't reduce these, and you can't reduce those. It doesn't work. Because in order to reduce, you'd have to apply the commutative property. Well, the commutative property doesn't work for division. So, first thing you're going to do, if you can reduce these, you do. If you can reduce these, you do. But if you can't, then what you're going to do is you're going to go ahead and rewrite the division as multiplication by the reciprocal. You see? Now there's something else that's tricky here. It's the exponents. But let's be careful. Let's be clear. Let's not confuse different issues. Let's not get overwhelmed with multiple points of confusion right here. Well, I'm trying to get this to focus. There. Oh, man. It's not really very good, is it? Anyway. So look, a times a is, of course, right? A squared. But check this out. We can reduce the 12 and the 14. Let's see. That's 6. And that's 7, right? Divide this by 2, divide that by 2. So what we've got is we've got 6 times 9. I'm not very good at math, but I think that's 54, right? Can't reduce this 7 and that 9 or this 7 and that 9. Here's the tricky thing, though. You see this exponent here? That means this is 7b times 7b. But you see this exponent here? This exponent is for the b. The 14 had an exponent of 1. If this was in the parentheses, so for example, if we had this, instead, I'm going to change it just a little bit, right? And the reason I'm changing it is I want to help you guys not confuse issues with exponents, that you might have, or with, these issues we're doing with reducing, okay? So look, this right here, 14b cubed is different than this 14b cubed, because this 14b cubed right here, means 14 to the power of 1 times b to the power of 3. So it really means 14 times b times b times b. Whereas this one means, this one right here, 14b, cubed. Oh, now it looks like a picture in the yearbook, right? 14b, cubed. That means 14b times 14b times 14b. Right? So totally different because of the group. This parentheses makes this a group. So this one's different. This is b cubed, not 14 cubed. All right, so anyway, let's get back to this one right here. We got 7 squared times 7. Well, that's 7 cubed. That's 7 cubed. And we've got b squared times b cubed, which is b to the 5th. And there we go. So let's talk about that one again. Let's review this one again. Let's go ahead and start over, right? What we had 12a, 7b squared. Sometimes when you see things the second time, it's clearer, and there's some extra issues here that I want to make sure are good. Okay, so here's what we got, right? We're going to rewrite this one. We're going to have 12a over 7b squared times 9a over 14b cubed. Now that we have multiplication, now we can reduce if possible. There's only one thing to reduce, the 14 and the 12, right? So what we got is we got 6 times 9, which is 9, or 6 times 9, which is 54, and we've got a times a, which is a squared, right? In the denominator, we have 7 squared b squared. Now, I know 7 squared is 49, but I don't really want to multiply it by 7. I guess I could. 28, 343. So if we wanted to write 343, we could. Here's b squared times b cubed. B squared times b cubed is b to the 5th. The reason it's b to the 5th is b squared is 2b's, and it's multiplying, right? And b cubed is 3. That's 1, 2, 3, 4, 5. Anyway, that's how that one works. So, let me give you guys just a couple of problems that you can practice here, see how this goes. And, yeah, we'll go from there, shall we? So, first one, here we go. If you're in my class, you can send me an email with your answers. You can put your answers in Google Classroom, whatever. If you can also leave them as a comment below. If you have questions, leave them as comments below. I'd love to hear from you. I'd love to hear how you're doing, what you're struggling with, how things are going. So let's try this one right here. Oh, that one's kind of tricky. And then let's try... Ooh. Try those two. See how they go. Leave me a comment. If any questions you guys have, be patient. Give yourself the time you need to learn this. It doesn't really matter how long it takes you to learn it. Only matters is the end result, that you do learn it. Then things will be easier for you in the future, and it's easier to learn it now than it is later. So, anyway, I hope you guys have a great day. Hope to hear from you. Be safe.